All right, guys, welcome to Math Analysis for March 27th. So, what you see before you is a cheat sheet of sorts that I've made for you guys that'll help out over the next couple of days. So, if you've been following along with what we're doing with derivatives so far, you know that whenever we have a function, whatever that function is, whether it's f of x squared plus 2 or f of 4x to the third plus 3x squared minus 7x, whatever. What we do is we substitute x plus delta x in for x in that function, and then we have to solve it. That involves the process of foiling or extensively multiplying this x plus delta x times itself multiple times. Now, typically, whenever I've taught this in the past, this is something that I ask the students to do themselves. It gets you practice multiplying things like this that are more conceptual and a little bit less numerical. But since you guys are at home, there's some distance, it's a little more difficult to ask those kind of questions and check your work. I went ahead and did that for you guys. What you see before you is the answer to x plus delta x squared to the third and to the fourth. So I would recommend pausing your video right now and writing these down if you haven't already. Because anytime we have a function that is going to ask for this squared or to the third or to the fourth, this is exactly what we are going to substitute in. So this way you don't ever have to write that out yourself. Because during derivatives, the only time we're ever going to be foiling is just with this binomial. We're not ever going to have anything crazier than that because this equation always stays the same for us. So I know I had mentioned that we would maybe look at the packet today. The reason we are not doing that is because I just took a look at the packet myself. I realized the other day I did not print off myself a copy of the packet. So I started looking at it on my Google Docs last night where I have it saved, and I realized the packet starts a little bit farther into derivatives than I had believed. So we're going to do another couple practice examples before getting into that packet ourselves. So here's what we're going to do today. I'm going to pose a derivatives problem, or a function. We are going to find its derivative, and then we are going to graph it and see how that derivative makes tangent lines with any given point that we choose. So this is going to be a two-part video. The first part of this video is going to be right here on paper. That'll be on the Google Classroom, as you're on right now. And then the second part will be right below this in a second video in the same post. So I'm going to make our function. I'm going to move to a second piece of paper, but we're going to bring this one back to reference. I'm going to make our function f of x equals 2x to the third plus 5x. That'll be the function we want to find the derivative of. So this is going to be, again, kind of a tough process, but follow along with me here. We're going to try to make it as easy as possible. So we know our derivatives equation is f of x plus delta x, or the function where we substitute this in instead of x, minus, I accidentally wrote equals, but minus f of x, just the function as it normally is, over delta x, which if you recall to the other day, doesn't come in for quite some time. You know, we don't really deal with that for a while. So here's what I'm going to do first. I am going to begin by plugging in x plus delta x for this. That means my function is going to look something like this. F of x plus delta x would be 2 times x plus delta x to the third plus 5 times x plus delta x. That's what this is going to look like. Now what I am going to do is I'm going to utilize the reference sheet that I put on here a minute ago to plug in what I need to, or what I can expand in terms of my binomials that have exponents. So I have one of those in this problem. I have x plus delta x to the third. So I'm going to rewrite this, but in place of x plus delta x to the third, I'm going to write this expanded polynomial. So this would be 2 times x to the third plus 3x squared delta x plus 3x delta x squared plus delta x to the third. Now the second part of this equation doesn't really change much, right? Plus 5 times x plus delta x. There's no exponent, there's no foiling or multiplying involved with that. Now we're not quite done with the equation yet. We still have that 2 and the 5 out there as coefficients. As you guys very likely know, what those coefficients are going to do is distribute into everything inside of the parentheses thereafter. So I'm going to go ahead and simplify this with that. And I'm going to write it right here because that's where we're going to put it with our the rest of our function in our answer. So we're going to have 2x to the third. Then 2 times 3 will make 6x squared delta x. 2 times 3 again will make another 6x delta x squared. And then 2 times delta x to the third will just be 2 delta x to the third. Then we have plus 5x, and then 5 times delta x. Now we want to see, is there anywhere that these can plug in, or not plug in, sorry, combine like terms? We already did our plugging in, our substituting in, but is there any like terms we can combine? Now, unfortunately, we don't have any of those because we not only need it to have the same combination of variables, but the same exponents as well. And we just don't have anything alike here. So these are going to remain one long equation for now. Now I'm going to fill in the rest. Minus f of x. Now you can do this one of two ways. You can write minus that whole function and then distribute the negative, or you can just subtract each term individually, and that's what I'm going to do. So for the minus f of x part, I'm going to say minus 2x to the third and minus 5x. Okay, perfect. And all of this is going to be over delta x. Now, once we substitute this information in, what's going to happen is we will very likely realize that some of this can cancel out. Some of this is going to actually be able to combine like terms now. And we're going to see this every single time we're going to see this. So if you're not seeing this, then something may have went awry. Our first term, 2x to the third, is going to cancel out with our first term in the second part of this, the f of x part, minus 2x to the third. So those are going to go away. Then we are going to have another term here, 5x, that is going to cancel out with this minus 5x. Those are going to go away. At this point, there's nothing else there that we can combine in any way. So we are down to just 6x squared plus delta x, or sorry, my bad, 6x squared delta x, accidentally put a plus in there, plus 6x delta x squared plus 2 delta x to the third plus 5 delta x, all over delta x. Now, if you guys recall again from the other day, the really great thing that happens at this point is that we have a delta x, at least one delta x in every single term. And since there is a delta x in every single term, just like if every number in our problem was divisible by 2 or something, we can cancel it out. We can factor that out. We can eliminate it. So that's what I'm going to do. We're going to wipe out that delta x. We're going to wipe out one of these. These three are going to just turn into 2. That one will go away, and that one will go away. We eliminate one delta x from every single term in this entire fraction. By eliminating those, we are left with 6x squared plus 6x delta x plus 2 delta x squared plus 5. And then our denominator, since we canceled out the only thing down there, is just remaining as 1. So we don't got to write that denominator at all. So this is what the equation looks like after canceling out 1 delta x from every single term. The final part of finding a derivative is acknowledging what delta x really is. Because again, don't forget that a derivative helps us find the slope of a single point, of an instantaneous point. If you're looking for a single point, then there can't be a change in x, right? There is only just x. So that change in a single point would be 0 because it's not moving. It is just 1 and 1 alone. So the final step is for us to acknowledge that delta x is actually 0. Now, regardless of what this other stuff is, if you put a 0 in there and these are multiplying, what's going to happen there? They're going to get canceled out. They're going to become 0 because 0 times anything is still 0. So by plugging that 0 in, 6x times 0 and 2 times 0 squared, these terms are eliminated from the problem. That leaves us with only 6x squared plus 5 as our remaining derivative. And this, in itself, is the derivative of our original function, 2x to the third plus 5x. Now what we are going to do is I'm going to transfer over to the computer here, and I'm going to end this video, and you'll have a second video on the channel. We are going to graph this original function. We are going to use this derivative to find the slope of different coordinates or different points in this function, and we are going to show that they create a tangent line at those points. So thanks for watching, guys. I'll see you in the next video.